Thank you. I hope you're enjoying Zagreb and conferences up till now. So, as we said, today we will talk about automatic dynamic malware analysis. So, here is a brief content of the presentation. So, it is divided into two parts. The first part, I will talk about malware analysis in the general, and in the second part, we will talk about distributed analyzing. So, if you want to scale up your analysis up to hundreds, thousands of millions of thousands of samples per day. So, let us begin with defining what malware analysis actually is. It is a process of dissecting malware to understand how the malware works, how does it impact the system, and how we can identify it, and what's most important, how can we defend against it, or how can we eliminate the threat from it. There are two fundamental approaches. The first one is static analysis, and the second one is dynamic analysis. So what are the differences? So the most important difference is that static analysis doesn't execute the malware, while dynamic analysis you need to execute the malware to see what it does. So in static analysis you will go to the signature-based approach. What does that mean? You will need to find out metadata about files. You will need to know about file fingerprinting, so hashing the file, the unique identifier of a file. You can reverse engineer the file, analyze memory artifacts, and so on. You will detect the packers of the malware, and so on. In the dynamic analysis, you are more focused on the behavior-based approach. What does mean? That you will observe what the sample do when it is executed. So you will watch API calls, instruction traces, registry changes, and maybe the most important, you will track the network traffic of the malware. So here I have some things about it. So basically, when you are analyzing statically, every time you should get the same results if you're using the same version of the software. On the other hand, dynamic analysis, and I will talk about that a little bit later, results may vary. So every time you execute the sample, results may be different. And dynamic analysis is harder intensive because you need virtualized environment to run your samples on. On static analysis, you don't need that. And basically, on the same set of the hardware, you could run, I don't know, millions of samples per day, while dynamically you can analyze it maybe thousands of them. So if you're more interested in malware analysis if you're interested in it, I would recommend reading this book. It's called Practical Malware Analysis, and it has great hand-on examples, and you can track it through the book. So, what we use for dynamic malware analysis is a software called malware analysis sandboxes. They basically execute the samples in the virtualized environment and track the behavior of the sample. Some of them are Cuckoo, Joe, Sandbox, FireEye, and VMRay. In Reversing Labs, we use the first three of one. We don't use VMRay yet. If you want to try it yourself, I would recommend using Cuckoo because it's open source, it's free. You can download it from the GitHub. You can modify it and run it at home, maybe on your dad's computer, but I wouldn't recommend it. So this is a typical sandbox architecture. So it doesn't depend on the software itself. This is like typical. So basically you have Sandbox host where you install and configure the Sandbox software. You need some kind of the virtual network which you will use to communicate with your virtual environment. For virtual environment you can use any type of the hypervisor. So basically you can use hypervisor type 1 or type B, type 2, doesn't matter. And every time you run your samples, you need to have clean state where the analysis will be run. And you need to isolate your network, because if you are running live malware on an isolated network, you can infect your environment and also infect other networks. So how does it work? When you configure it, basically Sandbox provides you with a web interface or API interface where you upload the samples. After that, he uses the virtual network to upload the sample to the virtual machine. The sample is then run, and what's most important in that part is that every time that you run your sample, you need to have clean environment. So what we are doing, we are using the snapshots. So basically, when you configure the first clean snapshot, that snapshot will be used every time. After the analysis, snapshot is reverted, so basically you'll get every time the same environment. When the analysis is done, Sandbox takes the metadata that was done in the analysis and creates the reports. So these reports can be in JSON, in XML, HTML, or PDF for human readability. So if your analysis was successful, you can see stuff like that. So I put here some examples where we run the samples on the virtual machines, and they were the sample was activated, and you can see that the virtual machine is now encrypted. So this is one also example. This one doesn't even let you to log into your operating system. As I said before, the results may vary on the dynamic analysis. This is because the malware authors know that we are running the samples on the sandboxes, and they are using anti-VM techniques. So basically, they are checking if the malware is executed in the virtual environment. They are checking if the sandbox is running in the background. And basically, some samples are also have context awareness. So when you run them, they will probably wait. They can wait, for example, for 2 weeks before they do something malicious to your infrastructure. So you can fight against that with proper configuration of the virtual environment. So basically, don't install VirtualBox additions or VMware tools, whatever you use. You need to change the default MAC address of your virtual machines and change the default hypervisor hardware signature. For example, this is how you can change default hard disk of the VirtualBox. So, yeah. And the other thing you need to be careful about is what I said before, it's your network configuration. You can go 4 ways. You can give no internet access to your virtual machines, and that will be good, but your analysis will be useful if you're analyzing, for example, downloader. And downloader is a malware that basically doesn't do anything to your infrastructure, but it downloads the malicious payload. You can go to the full internet access, which I would not recommend to you because your architecture will get exposed, your IP will get exposed, you could get blacklisted, you could have some legal problems, and so on. You can use InetSim. This is a software that basically simulates the network. So you have HTTP, HTTPS protocol, and all other network protocols, but your virtual machine doesn't have access to the internet. And the last, maybe some middle ground, the best approach is to route your traffic through the Tor or through VPN. What does that mean? That you need to know your IP tables, you need to know how to configure Tor, you need to know how to configure VPN so that traffic doesn't leaks out. So, up till now, we've talked about how to configure standalone machines, what you can use, for example, for home labs or small company environment or for threat analysts to use. So basically, someone will manually upload the sample and wait for the results. If you want to analyze, I don't know, tens of thousands of samples per day or 100,000 samples per day, you need to some infrastructure around the Sandbox solutions. So basically, the first idea would be to just add more servers. Well, it's not simple as that, because you need, what I said, services that will feed the system, services that will read out of the system. You need the queues for communication between services, some kind of storage where samples will be stored. You need automated configuration of new servers that you will add to your cluster. You need automated deployment pipeline and centralized logging and monitoring, like in the most large system. So, the first idea that we came up with in Reversing Labs was distributed analyzing with centralized control. So, what does that mean? When you are uploading sample to the system, you have a centralized manager or coordinator which will be responsible for everything. So he will be responsible to feed the sample to the workers, and he will be responsible for the state of every analysis that is run in the cluster. It doesn't matter if it is 5 of them currently in the cluster or it is 100,000 of them currently in the cluster. So it is backed by a central database, and when you are adding new servers to the cluster, you need to define them in the central database, so the manager is aware of the new resources that are put into the cluster. So, of course, this database cluster, this is a simplified picture. We are using a cluster of databases, and also storage cluster is actually distributed storage, Ceph we are using, and so on. But what is important here, that manager is responsible for each worker. So if you have thousands of workers, you will have thousands inputs in the queue, and every worker will just take messages from its dedicated queue. And that's what I said. What we decided after some time, we saw that basically you don't need centralized manager for this kind of jobs, because every analysis is a separate job. It doesn't depend, your end result doesn't depend on different sandbox outputs. So basically, we removed coordinator from the system, and control of each analysis is now up to worker. So it's basically the same architecture, but you can see it's simplified because you don't need to have database now, you don't need to have special software for distributing the samples, because the workers now read from the central sandbox queue. So if you have 3 sandboxes, you will have for each sandbox separate queue. It's like pool of tasks, and every worker will just ping the queue for the new tasks. This is simplified our whole process of adding new servers to the cluster, because now you don't need to have some special configuration adding to the database or something else. You just put new server in the cluster, configure it to run the sandbox on it, and you are good to go. And besides taking care of analysis, worker needs to do some other stuff. So it needs to clean after the analysis. What does that mean? So if you're basically analyzing hundreds of samples per day, your server will eventually get stuck because you will run out of the disk space or something. And also, it needs to take care of the virtual machines, because after some time, your virtual machines will get stuck or will get corrupted. And the worker needs to take care of that. He needs to repair or remove them from the virtual network. So this is our automation pipeline. Basically, what I didn't say about worker. Worker is basically a custom piece of software that we wrote, which is responsible for taking care of each sandbox. And when somebody is pushing changes to the GitHub, Jenkins is constantly looking for new changes. It builds it, and using the Ansible, it deploys it to the staging cluster. Currently, DevOps engineer is responsible for deploying to the production cluster, because we don't have so many changes in that part. And also, the DevOps engineer is responsible for adding new servers to the cluster. So basically, you get new server, you need to configure it, and you need to, I don't know, install necessary software, blah, 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 and you add it to the cluster. So basically, that is what we do. Here you can see also that we use some central monitoring and logging systems. So we use Grafana and Elk Stack, and we used Greylock up till recently. And we are also having automated alerting systems. So basically, if some server goes crazy or something, we will get alert and we will see what is happening there. What is interesting here, and maybe also for developers, that worker software is modular. So basically, you run the same package on every server, regardless of the sandbox underneath. And also, you don't care which environment or host is based on, because you create that configuration during the deployment. So that is the part of the deployment. So here we have, for example, that our deployment is structured that every environment has the host groups, and every host group has its own variables defined per each host. And you have one generic template which is checked on the deployment. It checks which host does it run on. It takes variables from that host and installs the software on it. And then you can basically have one package that can run, that you can deploy on all servers, and it will basically do the different thing based on the sandbox, for example, that is run on. You can see here, for example, VM profile to queue mapping, that it will read from this queue, and basically that it will initialize, in this case, Cuckoo20 module. So this is it for me. We have still 5 minutes for questions. If you have any questions, I will answer them. Any questions?
Thank you, Krešo. Anyone has got any questions? Yeah, we have one.
Can it happen that malware will escape the virtual environment?
It can happen, but for example, in our case, it happened once. So basically, we had misconfigured the network, and the malware basically scanned the rest of the network, and we got the angry email from the network provider that something is wrong with our architecture and that we are infected. So that was the one case. Because we didn't have some more serious than that, that it infected the whole environment or so on. Because the sample is run for a limited amount of time, and into that scope of time, it doesn't have time to do some damage. And also, the most malware that we run is run on the Windows machines, and the hosts are Linux machines, and you have AppArmor and software like that to protect your host from the possible leaks.
Okay, anyone else? No? So, okay, I got a question.
Yes?
What's the worst malware you found or scanned?
What's the worst malware that you found?
Like what?
Well, basically, in the last couple of years, there is a very popular crypto lockers. These were some examples that I've shown of. This is what we detect basically daily. But I think that maybe the most interesting that we've found out recently, that wasn't due to the dynamic analysis, were basically malware that were residing in the Python repositories, so in the PyPI and so on. Also in the NPM, we found malware there. I think that's very dangerous because developers are using that and they are spreading the malware. They don't even know that they are spreading it.
So do you only do analysis and scans, or does your company provide like implementations similar to firewalls or anti-malware software?
So for the main goal of our company is to scan malware, so statically, dynamically, using Yara and antiviruses to collect all the metadata from these approaches, to store this metadata in the database, and we basically give this data to our clients. So we don't provide any antivirus solution that you can use, but we provide data that antivirus companies can use, and other companies, they can ping our APIs, and they will know if the sample that are currently in their environment is malicious or not. That's the simplified view of basically what we do.
Okay.
Thank you.
Well, that's it. Please give a warm applause to Krešimir.